So let's continue section 2.7. Indeed, what we will do today, we will practice more about this section. Two main ideas are in this section. The first one, it is about the algebraic operations on functions. How to add, subtract, multiply, divide functions, and what will be the domain of the resulting function. The definition is here. F plus g is a function defined to be f of x plus g of x. The domain will be the domain of the sum. Let me write them here. The domain of the sum, the domain of the subtraction, the domain of the difference, and the domain of the product. All of them, the domain is just the domain of f intersection the domain of b. Find the intersection, and this will be the domain. Now, for the domain of the range, when you have f over g, the domain of the quotient, when you have the domain of the quotient, it will be what? It will be also the domain of the intersection, but you need here to add that the denominator is not 0. You have to consider this in addition to the intersection. We had this example in the previous class, if you remember about this. This is the sum, and this is the new function. Just ask yourself, what is the domain of this? It will be, of course, you have to consider the condition here and the condition here. So you need to find the domain of g and the domain of f. This is the domain of f, this is the domain of g, and this is the intersection between them. In the case, it is the same domain for the subtraction and for the multiplication. In the case of the quotient, you need to add a condition here that the denominator, which is g here, g of x is not 0. And if you remember, g of x, it was the square root of x is not 0. So x is not 0. So you will remove, it was closed at 0. So you should make it open at 0 to include the zeros of the denominator, to exclude the zeros of the denominator from the domain. How to evaluate these functions at specific value? You just apply the definition, f at 4 plus g at 4, and so on. The second part of this section, and it is indeed the most important part, it is the composition of functions. And we have defined this yesterday. What is f composed with g of x? It is f of g. It is the value of the function evaluated at g. It is not the subtraction, Shabab. Please don't mix up between it and between the subtraction. So this is not f g all of x. This is something different. What is this? This is f of x times g of, but this one, it is f evaluated at what? At g. So this is something else. It is f evaluated at g of x. Okay. Now, the main idea here that you need to focus also on is how to find the domain of the composition. It is not the intersection, not necessarily to be, it could be, but not necessarily to be the intersection. It could be the domain of G only, the domain of F only, or so it has a special way to be evaluated. How to find the domain? You need to think about all the values of X that make G defined. All the values of x that is in the domain of g, then g of x should be in the domain of f. In other words, this should be defined and this should be defined. So wherever these two expressions are defined, this is the domain of the composition. We explained this yesterday, not with this example, with another one. This example is easy because the domain here of the composition is all the real numbers. So no, there is nothing to worry about here. What is this section is, or this example is about this. It shows that the composition of two functions is not commutative. F composed with G, it is not G composed with F. How to evaluate the composition at specific value? Apply the definition. It will be F at G of 5. What is G at 5? Evaluate G at 5. It is 2. Here it is. F at 2, evaluate F at 2, and you will evaluate. Or you can use, of course, the expression that you have from here. Just substitute x by 5 here. I think this is the example that we didn't finish. We stopped last time at this example. Maybe we solved A and B. Is that right? We solved A and B. Let's go over the solution of A and B quickly and go to C and D. What we want here, we have F, we have G, and we need to find F composed with G, G composed with F, and we need also to find the domain. So even if he didn't ask about how to find the composition, he asked just about the domain, you need to find the composition to find the domain. So what is the way? Please pay attention. This is the only way that you have to do to make sure. Of course, there are other ways, but I believe that this is the best way. The best way is to start apply the definition. What you need F composed with G. What is it? It is F of G. So what is G? Ask yourself, what is G of X? It is square root of 2 minus X. 2 minus X. Ask yourself now where this will be defined, where it exists. If what is inside is greater than or equal 0. So this is the first condition that you should put. Now what you will do, you will go to F and put instead of X, you will put what? G, this one, the square root of G. You will put it here. So what you will get in that case, you will get the square root of 2 minus X. Is there any additional condition here to be added? Or this is enough? This is enough. No more restrictions we need to add here. Now what we will do in this step, we'll just simplify. The square root of the square root, it will be the fourth root of 2 minus X. And according to that, this is the composition of F and G. And the domain is what? If you solve this one, what you will get? Negative X greater than or equals negative 2. X is less than or equals 2. X is less than or equals 2 means from negative infinity to 2. This is the domain of the composition F and G. Now, what about G circle F? G composed with F. It will be G of F. What is F of X? It is square root of X. So what is the condition that we need to put here? It will be G of G square root of X. What is inside here should be greater than or equal. So this is the condition that we should put. Now you will go to G. What is G of X? G of X, it is square root of 2 minus X. So what is G of F? It will be square root of 2 minus F. So just you will go to G, replace X by what? By square root of X. Here we are. So what we did, we just substitute X by square root of X. Now, this condition is still, of course, we need it here. Is there any additional conditions to be added here? We need also this expression, the radical here, inside the radical, we need it also to be greater than or equal 0. So this is now additional condition to be added when we find the domain of the composition. This is ready, and we cannot simplify here anymore. That's it. Now we need to solve this. How this will be solved? It will be negative square root of X greater than or equals negative 2. I do it this way, Shabab, just to be okay for you, but in fact it is easier than that. You can just write it as 2 greater than or equals square root of what? It will be much easier. Okay, even if you did it this way, no problem. So you multiply both sides by negative, so it will be less than or equals 2. I need to remind you here about when you multiply by negative, you will reverse the sign. What you have two positive numbers, you can square both of them and the inequality will be valid. So it will be what? X less than or equals what? 4. No absolute value here, X is positive. Now you have two conditions now. X greater than or equals 0, X less than or equals 4. What is that? How to combine these two conditions together? You need to find the intersection here. So it will be what? This is 0, this is 4. X greater than or equals 0, X less than or equals 4. Here we are. X is here. So the domain of the composition G and F is what? Closed interval 0 and 4. Now let's go to F circle F. What is this? What is F of F? It is F of F. What is F composed with F? It is F of F. What is F of X? It is square root of X. Now, again, you will put the square root of X inside the square root of X. It will be the square root of the square root of, what is the condition from here? X greater than or. No need to add here more condition because, yeah, Shabab, if you put this, someone Someone will say, well, we need this to be greater than or equal 0. It is. It is not a condition. And it is a fact. Always when you have an expression, that is greater than or equal 0 inside the radicand, the result, of course, it is greater than or equal 0. Always, this is from the definition of the radical. It is the positive square root. Now, this is the fourth root of x, where x is greater than 0. The domain of f, circle f, is what? It is square root, it is from 0 to infinity. We were lucky here because it becomes the same, but it is not always the case. Now, let's take this. G, circle G, G composed with G. It is G of G. What is G of x? Square root of 2 minus. What we will do now, again, it is G of G again. We will put, instead of x, we will put what? This one again. So what it will be? But before doing that, before going further to the next step, you should consider what is the condition here. It is 2 minus x greater than or equal 0. Now we will substitute in G, we will put in G x equals to the whole expression that we have here, G itself. Look, what is it at the end? Now, this condition is still there, but we need to add another condition. What is it? The whole thing here inside the radical should be what? Greater than or equal 0. Now, this one need to be solved, and this one need to be solved. So we will solve them together. And of course, it is about and. We need this and that. It is about the intersection here. So solve this one. How to solve it? You will move x to here. So it will be 2 greater than or equal x, or x less than or equals 2. And here the square root will be less than 2. Square both sides here. This is ready. Square both sides here. And you will have 2 minus x less than 4. Now move x to here, 4 to here. You will get x greater than or equal negative 2. And less than 2 and greater than negative 2. What is that? No, this is negative 2. This is 2. This is infinity. This is negative infinity. X is less than or equals 2. So here it is. X is greater than or equals negative 2. Here we are. And if they are overlapping in the interval negative 2 to 2. So the domain of the function g of g, it is from negative 2 to 2. Is it the same as the domain of g? No. It is not. Okay, so it is another function, a new function. You should consider this. What we have learned from this so far, Shabab, who can answer this question? If someone asks you how to find the domain of the composition of two functions, what will be your answer? Okay, let me go back to the sum and the difference and the product. How to find the domain of the sum or the difference of the product?
Can I answer the question?
No, answer this question now. Yes.
Find the domain of x, of number, and the intersection with the domain of g.
The domain of f plus g will be the intersection of the domain of f and the domain of g. This is the answer, easy in that case. Now here, in the case of the composition, how to find the domain of a composition of two functions? Yes.
For example, we have f and g.
Okay.
F of g, we'll find the domain of g beside it. We'll find it. And then the domain of the composition and this instruction between the two domains.
Kind of, you are right. Yes. The idea is, if you want to find the domain of the composition, what you need to do, you need to find the composition step by step, and you need to consider the domain of each expression that you have involved in the calculation. Again, to find the domain of the composition, you need to find the composition itself step by step and find the domain, the values of x that is make the expression real number or defined in every step. Let's take another example to make this more clear. Let's take this one. Look at this, easy functions. F of x, it is 6 over x minus 3, and g of x, it is 1 over x. Now find f composed with g and its domain. What we will do? We will use the definition. What is this? What is f is composed with g? It is f of g. What is g of x?
1 over x.
1 over x. Now, before going to the next step, what you should say?
The last equals here.
Allah yarda alayk, Abdul Aziz. Yes, x is not 0. Next, we will go to f. Here it is. Replace x by what?
1 over x.
By 1 over x. Here we are. Do we need another condition, or the old one is enough?
We need another
What is that?
1 over x math 3.
The denominator, this denominator is not 0. So we need now to say that 1 over x minus 3 is not 0. And also x is not 0. All the condition is still there. Now this means that 1 over x is not what? 3, which means that x is not third. Okay? So let's continue. Now we can, of course, simplify here. We can now write this as what? 1 minus 3x over x, this one. Simplify, because x is not 0. If x is 0, we cannot do that. So simplify. This is what you will get. And the conditions are what? X is not 0, x is not a third. This means that the domain is what?
All the real numbers except
All the real numbers except 0 and third. So it is from negative infinity to 0, union from 0 to third, from third to from third to infinity. Okay, look here. What is the possible mistakes that you may do when you solve this? If you didn't consider this condition, if you forget it, and you forget this, and you just calculate this case, and here we are. What will you say? What is the domain of this? All the real numbers except third. And this is not true. Why? Because you forgot to consider the domain of what? Of G. So you need to consider the domain of G and then consider the domain of the final expression that you will have. Okay? Excellent. Let's take now G circle F. G of F. What it will be?
G of
It will be G of 6 over x minus 3. So what you will do, you will go here and replace x by what? By 6 over x minus, but you need to put some condition here before. What is it? You should have this. It should exist first, so you can use it. So what is the condition here?
x is not
X is not 3. X is not 3. Now, if x is not 3, you can do whatever you want with this expression. You will go to G, replace x by 6 over x minus 3. This is what we will get. Do we need another condition, or the old one is enough? What is the condition that we need? We need this to not be 0. I know what you are thinking about. You will say this is not 0. And it is not 0 indeed. How it can be 0? Give me x that makes this 0. 3, it will make it 0? No. The expression. I'm talking about the whole domain here. The whole denominator here. It will not be 0 at 3. It will be undefined at 3. When you have a over b equals to 0, this will be f and only f what, ya shabab? If a is 0, I'm talking about b is not 0. This is 6. How it can be 0? So this is never ever will be 0. Just there is no need to add more restrictions. This is enough. X does not equals to 3. This is more than enough. Now you can take the reciprocal, because this is 1 divided. Look at the main fraction bar, because you may do a mistake here. It is 1 divided by 6 over x minus 3, which is 1 multiplied by x minus 3 over 6, which will be, of course, x minus 3 over 6. Now look at the final. What you should, when you look at it, if you forget to put this condition, what you will say? What is the domain?
all the real
All the real numbers, no problem. So it is about the final expression and consider the domain of G. Yes, here it is all the real numbers, but if you look at the domain of F here, what is inside, it is all the real numbers except 3. So you need to find the intersection of the domain of F and the domain of G of F here. All the real numbers except 3. You got it, ya shabab? Now I think we still have like 2 or 3 easy exercises or examples. This is about when you have composition of many functions, not only 2. You can have as many as you want. G, F, composed with G, composed with H, and so on. So let's compose the 3 functions together. You have F, you have G, you have H. What is F composed with G, composed with H. It will be F of G of H. From where to start? From insider to outside. From H, then G, then F. What is H of X? X plus, you will put instead of X, X plus, instead of H, X plus 3. Then you will go to G, this is G. You will go to G and replace what? Replace X by X plus, what it will be? It will be X plus 3 all to the power 10. Now, finally, you will go to F, replace X by what? By X plus 3 all to the power 10. Here we are. Now, he didn't ask about the domain here, but if he asks about the domain, what you will do? Is there any conditions here? What about this? What about this? You need just to put the denominator is not 0. Of course, it will be very here. It will not be, by the way, because this will not be never ever. This will be ever never equals to a negative number. So it will be all the real numbers except. Is there a number that will make the denominator equal to 0? If you put X plus 3 plus 10 plus 1 equals to 0, this means that X plus 3 all to the power 10 equals to negative 1. Is that possible?
No.
No, it is not, because this is always positive. This is always negative. How positive equals to negative? It will not be a real number. Okay, now, this is much easier. What do you think? Which is easier? If you have F and G and you need to find F composed with G, or when you have the composition and you need to find what is F and what is G? What is given here? What is this? This is the composition. The question is, if this is the composition of F composed with G, what is F and what is G? Yes.
I can say if the fourth root for X plus 3.
F of X, it is the fourth root
of X plus 3.
of X plus 3.
And G is X plus 3.
This is
X
no.
plus 6.
No, no. You can check, by the way. You can say whatever you want, but check. Yes. It is not unique, by the way. There are many possibilities here. You can have many functions that compose to have this function. Yes. The fourth root of X. X plus 9. Let's check if you are right or not. What we can do? What is F composed with G? It will be F of G of X, which will be F of X plus 9. Go to F, replace it by X plus 9. You're right. This is one way. Who can tell me another one? Yes. A square root of X. Square root of X plus 9. You're right. This is also another way. You are right. Totally right. Excellent. You can, of course, have other possibilities. But this is, I believe this that what Muhammad suggests here. It is the initial idea. You can also may have. This is also not a bad idea. Good idea. Now, this is the summary of this section. Again, as I told you, it is about algebra of functions and composition of functions and their domains. Okay. This is similar to what we just have solved now. Who can tell me? What are the possible functions that we could have here as F and G? Yes, please.
G is 1 plus square root of G of X.
So we can put G of X here to be 1 plus square root of X. And F will be what?
Square root of 1 plus X.
No, it will be too much if you did that. Let's try. You said square root of 1 plus X. Is that right? Let's go and apply it. Let's try if it's correct. What will be F of G? Because he asked about F circle G. It will be square root of 1 plus. Instead of X, we will write G of X. What is G of X? It is 1 plus square root of X. You are not right. This will be 2.
We will make G square root of X.
Aha. This is a good one. Yes, this is square root of X. You're right. I think this is the first thing I thought even about. I thought about it like that. Who can give me another idea? There is another option here. There are many, but let's think about the practical ones. Yes. F of X is Oh, this is so easy, so trivial. And you will take everything to be G. This is the identity. Yes, it is possible. It is an answer, but it is not practical because you have to choose G to be the whole function now. This is it's correct, but it is an option. It is not practical. This is what I mean. It is not wrong, but it is not the best choice here. This is good. This is good choice. Any another idea? Yes, Khalid.
F of x would be square root of x.
F of x will be square root of x.
And g of x would be 1 plus square root of x.
1 plus square root of x. You're right. I think this is the same that I thought about also. So these are, I think, the two practical, let's say, options. Of course, when you have the one of them is the identity g of x equals to x or f of x equals to x, this will be trivial. Okay, now please, ya shabab, solve this one in your notebook. Try to solve this one. And during that, I will take the attendance. I think it's okay. Yes. Let's distribute the grades of semi-quiz number 2. Okay, it can be done by different methods. This is the answer. Check your answer. So one way is what? I'd like to do it this way. Let's close the composition. Here you have f, you have the function f and the function g. So easy. What is given here? The graph of the function, this function. What is it? The composition of g and f has y-intercept at 3. It is all about this sentence here. How to write this sentence? How to write this sentence? How to express it? Yes. So this means when x is 0, this will be what? So this means that g circle f at 0 equals to what? 3. Excellent. Allah yarda lak. Nawaf? Ahmed. Ahsant ya Ahmed. G circle f at 0, it is what? It is 3. This is the meaning of this sentence. How we translate it to notation, mathematical notation. Then find all the values of what? Of k. Now what we will do? We will find first this function. Can we? Yes, because we have f and we have g. So this is the composition. What is this by the definition? This is g of f of x. And this will be what? G of, what is f? X plus k. We will go to g. We will replace what? X by what? This is, here it is. This is the function. Now we will go to here. We will just substitute by what? By 0. This will be equals to 3. The greatest integer of k equals to 3. And this means that k is greater than or equals 3 less than 4. What is all the values of k for which the greatest integer is 3? Whatever the expression here, Shabab, like if you have what we give you yesterday in the quiz, whatever you will have here, it will be between 3 and what? I think yesterday you were having like this in the. If you want to know where it is at 3, you will just put this one between 3 and -4. The same idea. You will solve it for x then. Okay, let's solve the next one. Again, during that, please to solve this one, please. And it is multiple choice. Give me your answer. Try to solve it in your notebook, please. So let's check first that the answer is 32. Now, how it can be done? Muhammad, how you obtained 32? What you did? Why? The concept. We need to focus on the concept, ya shabab. Because if you have any trick, whatever the kind of question that you have, if you know the concept, you will solve it. Why? You will subtract. So you should do one step before. Give me the one step before you subtract. You have f. The question is about what? You have f. You have f composed with g, and you want what? G. So you have f. You have the composition. You need to find g. This is the idea. So what you will do? You will ask yourself, what is f composed with g? What is f composed with g? It is given here. It is 12 plus 8x plus 2x squared. By the definition, what is this? This is f of g. This is f of g of x. I don't have g. I want to find what is g. Add 2. But we can find g in general. Now, this will be equals to 12 plus 8x plus 2x squared. Now, ya Muhammad, what you will do here? No. The concept. What is f of x? X plus 4. What is f of star? Star plus 4. F of whatever? Whatever plus 4. So what is f of g?
G of X plus 4.
G of x plus 4, Abdurrahman. Excellent. Yes, that's it. 12 plus 8. You know now, Abdurrahman, ya Muhammad, why you will subtract 4? This is the concept that I'm talking about. Now, whatever the kind of question that you will have, it is not about subtraction or adding here. Now you need to find what? G. By the way, we can do the same from the beginning with x equals to what? To 2. I will show you that, but let me finish this. So g of x will be now what? Now add 4 for both sides. Solve it for g. Why we are subtracting 4 here? We need to solve it for g. So this will be what? 8 plus 8x plus 2x squared. I have g of x, the whole function. Now, if he wants to evaluate it at 2, at -2, at 0, at whatever, I can find it. Now, this is g of what? 2, which will be 8. Be careful here. Some students, they do mistakes here. Look what will be the sad end here if you did a mistake after all of this effort. And this, of course, will be like this. It will be 8 plus 16 plus 4 times 2. It is 8, which is 32. As I told you, you can do that from the beginning with 2. You can do that from the beginning with 2, and you will have the same answer. But here, what I try to show you that you can find g of x in general. If he asks you how to find g of x. Clear? Let's go to solve this one. I think we still have time to do that. Again, I will give you time to solve it in your notebook, and I will pass through and see who solved it, who is not. Let's see. It is about the domain. Find the domain of the quotient of two functions. Where it is? Right. Excellent. Khalid? Right. Excellent. Anyone, Shabab? Anyone else? Right. Excellent. Turkey? Write it in terms of intervals. No, unfortunately, you did a mistake here. There is a mistake here. Check again, check your calculations. Okay, let's see. Right. Muhammad, no, this is too much, yeah, Muhammad. Why? No, what is the problem? Is there any problem at 3? Check. What is the problem? It is f over g. Okay, let's see together, Shabab, because we don't have much time. So this is about f over g. F, this is the answer, by the way, if you want to check. It is about f over g, the quotient. So by the definition, if you want, you can do it in 2 ways. One way is to find the domain of f, the domain of g, find the intersection, then add to the restriction that g of x is not 0. But let's do it this way. What is this by definition? What is f over g at x by definition? It is f of x over g of x. So what is that? What is f of x? It is square root of 9 minus x squared over, what is g of x? X squared minus 2x minus 8. This is the function now we need to find the domain of. Don't simplify if you want to find the domain. Find the domain, and then if there is a cancellation or anything, there is not a cancellation here. But I'm talking in general, when you want to find the domain first, and then do what you can do. So now the domain of f over g will be what? X such that what? We have radical, so what is inside the radical must be greater than or equal, and the denominator, we have denominator here, and the denominator is not zero. That's it. Now we need to solve this inequality. How to do that? It is about what? X squared less than or equals 9. You can do it this way. 9 greater than or equal x squared. Now take the square root of both sides. What you will get? I prefer to write it this way. So it will be what if you take the square root of both sides? The absolute value of x less than or equals 3, which means that x is between 3 and negative 3. This is what we have from this branch. Let's continue here. To solve this, to know where it is 0, you need to know where it is 0, where it is not 0. You need to factor. So it will be x minus 4, x plus 2. Try to factor. Don't go to the quadratic formula if you can factor. Now this means that x minus 4 is not 0, and x plus 2 is not 0. This means that x is not 4 and x is not negative 2. So we have now to consider these conditions on x. How to do that in the what is the best way to do that? The real numbers line, to avoid any mistake. So let's start with the interval here. Negative 3 and 3. Close between negative 3 and 3. Now we need to exclude 4. 4 is here. It is not included, by the way. It is already excluded. We need also to exclude negative 2. So here it is. We need to exclude negative. According to that, the domain of f over g will be equals to what? Here it is. This one. Here it is. From negative 3 to 3 without negative 2. You need to exclude negative 2. Is that clear? You had a question yesterday about the domain in the quiz, and there were a lot of mistakes. The same idea, the same concept. The same concept. If you know how to do that, let me stop the recording. I think this is enough for today. We will continue tomorrow.